Take-home quiz. Here we go. We're looking at momentum. We're looking at impulse. How much momentum does an 80-kilogram mass have if it's traveling at 22 meters per second? Well, momentum is just plain old mass times velocity. So it's going to be 80 times 22. I should be able to do that in my head. It's going to be 160 plus 60. 176? No, 1,760? 1,760 kilogram meters per second, or you could have said Newton seconds. 1 mark. I'm going to go all or nothing on that one. Is that right? Yes? Number 2, what change in momentum? What's another word for change in momentum? Impulse. Okay. Change in momentum or impulse is going to be, well, there's a few ways. I can either find this by going change in momentum is force times time, or I can go change in momentum is m delta v, which I've written as mv final minus mv initial. Let's see. You know what? I see an initial velocity. I see a final velocity. I think I'm going to go like this. mv final minus mv initial. Or I could go v final minus v initial first and then times that by m. It's going to be 220 v final 52 minus 220 v initial. Now I always read carefully, Tyler. I'm looking to see if there is a rebound, if there was a change in direction, if I was once going forwards and now I'm going backwards. I don't think so here. I think we're just speeding up. So I think v final is also going to, v initial is also going to be positive, and v final is going to be positive. So I'm going to get 220 times 52 minus 220 times 23. 6,380? Yes? No? Kilogram meters per second, or Newton seconds. I think, Isabella, you used the m delta v method. I think it was you that I was looking at. Am I not? Someone went 52 minus 23 first, and then times that by 220. That's using this. You could do the final minus initial velocity first, and then multiplied by the mass. Totally fine. B, what's the magnitude of the force? Isabella, what did I find in part A? It would be cool if there was an equation that had change in momentum and force in it. Oh, there is. So apparently I can find the force by going impulse divided by time, by going 6,380 divided by 58 seconds. Oh, works out evenly. 110 newtons, because it's a force. By the way, I asked for the magnitude because technically, I guess the force should be negative because it's in the opposite. Oh, no, we're going forwards. We're going forwards. Never mind. I take that back. Number 3, impulse. What's another word for impulse, James? Wants me to find the impulse. What's another word for impulse? I got to be fussy, not momentum. Change in. Just plain old momentum has no impulse. You only have an impulse if your momentum is changing, which means you have to have a final and an initial. So it wants the impulse. It says to rest. There's v final. Oh, there's v initial. I can do the same thing. It's m v final minus m v initial. It's going to be 80 times 0 minus 80 times 18. It's going to be negative. 80 times 18 is going to be 800 plus 864? No? Am I off? Maybe I am off. People are looking at me funny. Wow, I'm totally off. How did I do that? Because I forgot to carry a 0. It's 800 plus 640, a negative 1,404. Wow. Kilogram meters per second. I'm going to be fussy. If you don't have a negative, I'm going to take a half mark off, because it definitely in this case is negative if you go final minus initial. B says, how long It wants me to find time. Well, in part A, I found impulse. You know, Ty, it would be cool if there was an equation that had time and change in momentum or impulse in it. There is, you say? How would I get the t by itself, folks? How would I get the t by itself? By f. Okay. So, okay. The time is going to be the impulse divided by the force. It's going to be negative 1,440 divided by negative 270. Mr. Duick, why did you make the force negative? First of all, Braden, I know time is going to be positive. It's a scalar. And you know what? The force is acting in the opposite direction that we're going because we're slowing down too. Or you could have just, in your work, said, I know the answer for time is going to be positive. I'm not that fussy. Divided by, do you get 5.33333? Yes? 5.33 seconds. I'm going to be, again, 1 mark, all or nothing. And then I'm going to turn the page. Cool. Hayden, what's part A you want me to find?
Impulse.
What's another word for impulse? So I'm going to write this down. Then I'm going to go look at the question. I'm going to say, did they give me a force and a time? Or did they give me a final and initial velocity? I think they gave me a final and an initial velocity. So it's going to be mv final minus mv initial. Hayden, do you play hockey?
No.
Have you played hockey?
Yeah.
Have you played floor hockey?
Yeah.
Please tell me you caught that this is in grams. Please tell me you didn't say the hockey puck was 170 kilograms. Please? Okay. So the mass is going to be 0.17. Hayden, what's V final in this question?
43.
Okay. Minus the mass is 0.17. Hayden, what's V initial in this question? Don't say 22. Why can't he say 22? Pardon me? If he lets west be positive, he can't let east be positive, right? So you, as soon as you said west was 43, what have you just decided east is going to be? You should have gone negative and reminded yourself of that, okay? Or you could have let west be negative and east be positive. I don't care, but please look at the directions and take those into account. You have to. You have to. 0.17 times 43 minus negative 0.17 times negative 22. I got a positive answer here. Which way did you, Hayden, let be positive, west or east?
West.
So positive means west. Where am I, Mr. Duick? 3.57 kilogram meters per second west. Yeah. Am I wrong? Oh, hang on. I'm totally wrong. I put a negative and a negative. I put 2 negatives, you're saying? Do you get 11.05? Hey, that looks better. 11.05. In terms of part marks, if you have the 11.5 kilogram meter per second wet, you get 2 out of 2. Otherwise, I would probably do something like this. I would give you a half mark for that. I would give you a half mark if I saw that term. I would give you a half mark, but I would have to see that the velocities had opposite signs. Half mark for the answer. If you have the wrong direction, you would lose a half mark. Okay. Hey, Cam, what does B want me to find?
The average
Force, you say. What did I find in part A? Impulse. You know, it would be cool if there was an equation that had force and impulse in it, and there is. I guess the force is going to be the impulse divided by the time. Yeah, divided by t. It's going to be 11.05 divided by 0.025 divided by 0.025. Do you get 442 newtons? Now here, I didn't specifically say, by the way, the reason I said average force, I've seen hockey slap shots in slow motion. The stick flexes and gives, I don't think the force is constant. I think it changes, but that's the average force. That's why I put the word average there. So you said average force. That's when I'm a nerd hedging my bets saying, I don't think the force is constant. I think it changes. I didn't specifically say give me a direction, so if you didn't say west, I'm not going to take marks off. I guess here I would give you 1 mark if I saw that, half mark for that, and a half mark for the answer. And if you said west, yay! Key word in this question. Oh, first of all, I like number 5. I like number 5. I like number 5. Key word in number 5 is rebounds. Rebounds. Okay. Isabella, what's 5A asking me to find? What's another word for impulse? Changing something. Changing clothing? No. Changing hairstyle? No. Changing attitude? Oh, I wish for some of you. No. What? Hey, there we go. You know what? I looked at part B, Isabella. In part B, they're asking me to find the final velocity, so I don't think I can use final minus initial in part A like I have been before. You know what, Isabella? I think I'm going to have to go force times time. Did they tell me a force in this question, Isabella? Did they tell me a time in this question, Isabella? Woohoo! Do you get 15.3? Yeah. And here, I'll write Newton seconds because I did go force times time. But again, Nat, if you said kilogram meters per second, I'm good with that as well. 1 mark. You know what? I guess I'd go a half mark for that and a half mark for the answer. Hey, Nat, what's B want me to find? What did I find in part A? What did I find in part A? Sorry? You know what would be cool? If there was an equation that had impulse and a change in velocity in it. Turns out there is. I can write impulse equals mv final minus mv initial. Okay? Yeah. In the original question, see the original question? What word did I underline way up there? That means there's going to be a change in, I'm looking for a word that begins with letter D. Yes. Which means I better let one way be positive and one direction be. I see east and west. Let's decide ahead of time. You're going to decide. Do you want east or west to be positive? I don't care. Pick. East is positive, so I'm going to put a plus. I'm going to put a plus there. West is negative, and if I get a negative answer, that's going to mean... And if I get a positive answer, it's going to mean... Okay. What did you say we're trying to find in part B? That guy. I want to get it by itself. First, I need to move this over. How? Yes. Good. So... the impulse drops down plus mv initial. That's going to be mv final. How would I get the v final by itself? Okay, good. And if I get a negative answer, west, by your, and positive answer, east. Okay, let's keep going here. What's the impulse? Now, I got to be a little careful here. The magnitude of the impulse is 15.3. What direction is the impulse, west or east? Okay, it is west because the ball was initially going, which way is east for you guys? That way. And it stopped and ended up going this way. So because you let west be negative, I am going to have to let that there be negative as well. And that's the tricky part to this question. Plus, the mass is 0.15. 150 grams is 0.15. V initial, positive 39, divided by 0.15. Nat, is this a fraction? Is there more than one number on the top? Brackets. Hey, is there more than one number on the bottom? Okay, so I don't need brackets there. That plus 0.15 times 39 divided by 0.15. Is that right? No? Yes? No? Okay. Nah, this is. What does negative mean? Nat? Which way? Now, if you didn't get this was the tricky part. If you just said, oh, the impulse is 15.3 and you forgot that it had a directional component, then you would have got 141 as an answer. I will give you 2 out of 3 if you got 141. Okay? Otherwise, if you've got the right answer, great. Otherwise, I would give you 1 whole mark if I saw that. A half mark for that. A half mark for that. And 1 mark for the answer. And there's your 3 marks. Could you give yourself a lovely, lovely, lovely score out of, count 'em, 13, please? If you need to come lawyer with me, now is the time as well. Here we go. Hayden's done yawning. Hayden, I think they want me to find this mystery velocity right there. Hayden, my friend, is there a collision?
Yeah.
Is there more than one object?
Yeah.
This is a job for conservation of momentum. Tum, tum, tum. And so I said I start out by writing the sum or the total momentum beforehand equals the total momentum afterwards. Hayden, before the collision, what's moving? Car A, car B, both or neither?
Both.
Stuck together or separate?
Stuck together.
Before the collision?
No.
They can't because they're in opposite velocities, right? They're heading to, again, this is like a parking lot crash. One guy's going forwards and somebody's in reverse, not looking where they're going. Or smash up derbies, if you've ever watched that. Okay? So, momentum of car A on its own plus momentum of car B on its own initial. Hayden, what if one of these wasn't moving? What would its momentum be?
0.
And I wouldn't bother writing, I wouldn't write that term down. I wouldn't write a momentum B or a momentum A. Just leave it off. Is that okay?
Yeah.
Yeah? Good. Wham! They collide. After the collision, Hayden, what's moving? Car A, car B, both or neither?
Car B. Both.
Stuck together or separate?
Stuck together.
See it?
Yeah.
Okay. Now, this is from the picture. In the question, it'll either be obvious or you want a good example of a collision where it sticks together if you fire a bullet into a block of wood. The bullet and the wood stick together, for example. So there are some obvious ones where, oh yeah, they stuck together. So I'm going to say this then, momentum of both. Final. They're stuck together. Oh, and since they're stuck together, what's the mass of this big Uber object? Not 2,000, not 4,000. What's going to be the mass of this thing?
8,000.
6,000. 6,000. We add, we don't times. We add. 2 plus 4 is 6. Okay? Momentum is what times what, folks? mass times velocity. So momentum of A at the beginning is going to be mass A, VA at the beginning, plus momentum of B is going to be mass B, VB at the beginning, equals MA plus MB, V final. Right? Hayden, what are they asking me to find?
Velocity of car A.
I want to get this by itself. How? Oh, Hayden, I got to move this over. How would I move that over? What's right in front of it? Yeah. See how if you look at the equation, it does sort of tell you what to do by looking at how it's set up, yes? So if I hear you correctly, I think I do, you're telling me we're going to get this. Mass of A, VA initial, and then it's the mass of both of them, which is adding, V final. Subtract mass B, VB initial. Is that what you said? Say yes.
Yeah.
How would I get the VA by itself? How will I move that mass of A over? You would be correct. Can I just do this on the same line? Have we got the VA by itself? Plug and chug, baby. Here we go. Hayden, in your head, what is the mass of A plus the mass of B?
6,000.
Very good, Hayden. I knew you could get that. What's the final velocity of them after they stuck together? Look from the picture.
5.
Okay. Now you have just decided by saying 5 that to the right is positive. Okay? That's the, as soon as you make that call, make sure your brain notices what you've done. And then there's going to be a takeaway. What's the mass of just B?
4,000.
Yep. What's the velocity of B at the beginning?
-3.
Which one? 3 or -3?
-3.
Yes. All divided by the velocity of car A, which is 2,000. You know what? I think I can do this in my head. It's going to be 30,000 plus 12,000, 42,000. See if you get, I'm getting 21. Try this on your calculator, please, boys and girls. Hayden, is this a fraction? Yeah. Is there more than one thing on the top? Yeah. Brackets around the top. Is there more than one thing on the bottom? No? Okay, then you don't need brackets around the bottom. When I say I think I can do this in my head, that's really my way of saying I absolutely am pretty sure that I can get the right answer in my head. But thank you for confirming that. You get 21? Okay. Yeah. Positive or negative? Positive? So positive, am I going to say to the right or to the left, Hayden?
To the right.
That's what you decided. Okay. So that initial car must have been coming in at 21 meters per second. That's a meters. Wow, that's messy. Meters per second to the right. I'm going to ask a question, and this might tell you how old I am. If you look at situation D, when I was a kid, we called it ghost riding. Do you guys still call it that when you're a little kid? When you jump off and let the bike keep going in a straight line? Or is it no? Okay. Well, that's what we call it. Of course, you guys. Okay, fine. You're riding your bike and you jump off. Okay. Is this a collision? Sort of. It's a slow one, but it is. So you ready, Braden? This is a job for conservation of momentum. The sum of all the momentum before equals the sum of all the momentum after. And I think I said last class, but I'll say it again. Nevada, as you get good at this, you can start to skip a few steps. But this is very similar to if you do a free body diagram. This is I'll give you a half mark just for writing that down. You've identified the concept. Braden, beforehand, what's moving? Mass R I guess rider. The rider, the bike, both or neither. Stuck together or separate. Okay. So, momentum, both. Hey, Rob, you know what? They don't collide. Whoa! Whatever that. Oh, you know what? The rider jumped off. So after the jumping off, what's moving? The rider, the bike, both, or neither? Stuck together or separate? I guess this wants me to find the velocity of the bike afterwards. Okay. Braden, momentum is what times what? Mass times acceleration is force. Mass times velocity is momentum. So this is going to be the mass of both velocity initial equals the mass of the rider, velocity of the rider, plus the mass of the bike, velocity of the bike, and I guess technically both of these are finals. Braden, my friend, what's this question want me to find?
The velocity of the bike.
This guy. I need to get that by itself. Move this over. How? Yep, because there is an invisible plus sign in front of it. You can't see it, but it is there. It is positive. And then what would I do?
Divide the mass of the bike.
Feel like we can do that in one step? Yeah? You feel? I think we can. Okay. So I think what you're telling me is that the velocity of the bike is going to be, the one that stays where it is m both vi. You said we're going to subtract the mass of the rider, velocity of the rider, and you said we're going to divide by the mass of the bike. Have any of you ever, when you were a kid, or maybe even now, done this when you're riding pavement or a field where you jumped off of the bike? Any of you ever do this? Did you notice what happens to the velocity of the bike? Because your velocity goes down, your momentum goes down, what happens to the momentum of the bike? It increases. Does the mass of the bike increase? So what part of the bike must increase of its momentum? Yeah, it speeds up. It speeds up. Okay. Or if you could run down a bike and land on it, it would slow down because suddenly its mass has increased with the same original momentum. Okay. Here we go, Braden, my man, I hope. Mass of both, 80. V initial, I've scrolled down, 5. Minus mass of the rider, 60. Final velocity of the rider, -2 or +2? Are you positive? Shut up. Okay. Divided by mass of the bike, 20. $400 minus 120 is going to be 280. 14? Yeah. 14 meters per second. Forwards, or to the right. Could you ever get the bike to go negative? You could go backwards?
The bike could go backwards.
How? From this situation. It would be painful. Go ahead.
Instead of jumping off backwards, you jump off forwards.
So if you somehow balanced on your seat and you dove forwards as hard as you could and you're going to belly flop or what, but okay, that might be enough forwards momentum that you might have actually gotten more momentum than you started with which means the bike has to pick up some negative momentum because momentum is conserved. In other words, right now, the momentum is 80 times 400. Let's suppose you managed to jump forward with 500 kilogram meters per second, then the bike would have to have negative 100. It would have to go backwards. You may have experienced this not on a bike, but if you've ever been playing in the water, balancing on an inner tube. If you're at rest, what's your momentum right then? 0. If you dive forwards with a positive momentum and your original momentum was 0, the inner tube has to move backwards with a negative momentum, which is why it goes shooting out from under your feet and you belly flop. Okay? Let's do actual word questions now. Here we go. Example 6. A car traveling collides, here we go, head on with another car traveling in the opposite direction. If the cars stick together on impact, this is how I said, instead of a comic strip, the words will be pretty obvious. What's the velocity of the wreckage immediately after the impact? Hey, Cam, is there a collision? Yeah. This is the job for conservation of momentum. The total momentum before equals the total momentum after. Cam, I want to be organized and lazy. You know what? Let's call the first one car A. And I'll just put an A above it. What will I call the second one, Cam? You can. I thought he was going to say C for Cam because, you know, him. You all right? Okay. Do you see that there's something happening in an opposite direction here? Do you see that there's something happening with like an opposite direction kind of a dealio here? We better let one would be positive, one would be negative. Do you want the 44 to be positive or negative? I don't care. Pick. That means I'll put a negative right there. Yeah? And if I get a negative answer or a positive answer, that'll help me determine which way it's moving. Hey, Cam, before the collision, what's moving? Car A, car B, both or neither? Stuck together before the collision or separate? Momentum. Are you seeing it's kind of repetitive, I hope? And this is where you can start to take shortcuts. In our notes, we won't. Momentum of car A initial plus momentum of car B initial. Bam! They collide. After the collision, Cam, what's moving? Car A, car B, both or neither? I don't think so. You know why? If they're asking me to find the velocity after the impact and none of them are moving, then the answer is 0, and this is a stupid question. Both. Stuck together or separate? You okay with that? Cam, momentum is what times what? So this is going to be mass A, velocity A initial, plus mass B, velocity B initial, mass both V final. You could write mass A plus mass B or mass both. Long as, Hayden, you remember that you're going to add, not times, we can write both. Okay? It's less writing. Cam, what's this question want me to find? Which one? There's 3 in my equation. That guy there. Oh! This isn't going to be bad at all. How would I get that by itself? Which M? There's 3 M's. You know what? Let's do this right now. Jump. That worked cleanly. And I think I told you this is the start of the physics of accident investigations. Now, in real life, as soon as the wreckage happened, then they would start to skid. Although skidding is friction, it's mu times the normal. We could actually work out, because that we could calculate the force and the time and get the impulse and how much momentum we lost to friction as well. I'm going to keep it simple. And that's why I said immediately after impact. Or I'll do a question like number 7, we're curling on ice and we can ignore friction. Okay. V final, Cam, is going to be the mass of car A. Cam, what's the mass of car A? which is, I think, 1,500, which is less typing. What's the velocity of car A? I agree. And then there's a plus sign. What's the mass of car B? Nice, even 1,000. What's the velocity of car B?
22.
No.
Negative
Okay,
22.
we can't be doing that. We got to be focused on the change and be able to remember that there's a change in direction. Cam, did you write a negative in front of the 22 when I told you to?
I did.
Okay. Okay, and that's, to me, and don't take this wrong, that's silly because that's such an easily preventable error, and it takes all of, what, a tenth of a second, right? You've had me long enough to know, Cam, I am not going to give you long, convoluted ways. We're going to be as brief as possible. Divided by the mass of both 1,500 plus 1,000. Cam, is this a fraction? Is there more than one number on the top? Is there more than one number on the bottom? There is now. Brackets and brackets. Dude, this one in your head, Mr. Okay, maybe. I'm not going to whip out. I did add the two masses below in my head. I can do that much. Yeah? Is that right? Or am I wrong? Is that right? Okay. So the first car is heavier and going faster. The second car hits it head on, and then both of them keep moving this way. The people in the second car undergo a much bigger acceleration and therefore have more damage. This is like a locomotive running into a small car. This goes back to earlier I said it's not the impact that does the damage, it's the acceleration that does the damage. I'll put a positive sign in front of it. If the question had said east and west or north or south, I'd give east or west or north or south in my answer, but we're good. Sure, let's do example 7. I was trying to debate here. I want to cut corners and give you lots of time to work. Do I have 7? I have 8. Is 8 the last one? Yeah, okay. So I'll do 7. We'll just talk about 8. Kareem, you awake? I don't think you were. I think you were zoning. You ready? Kareem, it says this, an 18-kilogram curling stone is traveling due east at 2.6 meters per second. It strikes an identical stationary. All of us underline the word stationary, curling stone. After the what? Collision? This is a job for conservation of momentum, I think. The first stone is moving, blah, blah, blah. What's the final velocity? Okay. Kareem, is there a collision? This is a job for conservation of momentum. The total momentum before equals the total momentum after. Kareem, I'm going to call this stone A. I'll call this one, the identical one, stone B. Okay. Before the collision, what's moving? Stone A, stone B, both or neither? Oh. Bam, they collide. Come on, you got to be on the same wavelength. Come on, I paused, man. Okay. After the collision, what's moving, Kareem? Stone A, stone B, both or neither?
The first stone.
I disagree. What are they asking me to find?
Yeah.
Of what?
Of the second stone.
So, after the collision, what's moving? The first stone, the second stone, both or neither? Stuck together or separate? They're curling rocks. I'm pretty sure they're separate. Yes? Solve the rest on your own. I'll do it slowly up here. If you get stuck, you can ask, but move on ahead if you can. Momentum is mass times velocity. Another really good example, if you play pool or billiards, those are some beautiful momentum collisions. Jeez, dude. Don't just copy. Try and figure this out. Okay? They didn't tell me the mass of B. Oh, they said identical. 18. Oh, I can do this one in my head. 1.95? Yeah. Because all the 18s cancel. I can factor it out. I got a positive answer. What did I let be positive? East. Okay. This is the law of conservation of momentum. Momentum is conserved. In example 8, I noticed there's an east and there's a west. I'd let one way be positive, one way be negative. I would probably let east be positive and west be negative because that kind of makes sense to my brain. Okay. But I'm not going to do it. Number 1, number 2, number 3. Number 4. Most of those questions, those 1, 2, 3, 4, are conceptual. You don't need to show any work. You're just going to ask, can I figure this out? I don't think I included the answers. I'll go over the answers next class if you want to. Okay? Oh, Calvin and Hobbes. We'll try number 5. A little more Calvin and Hobbes, number 6. Seven is good. Eight is good. I'll go do 9, skip 10. For those of you that are football players, 11 is the physics of the goal line stand, which is a great collision. It's a great example of conservation of momentum, especially if the running back is leaping and is in the air, because while he's in the air, he is a closed system. There are no outside forces or sources of energy. Okay. Try those.